In this video, we are going to use implicit differentiation to find not the first derivative, but to find the second derivative. Now, I say to find not the first derivative. That's not really true. We do need to find the first derivative initially prior to finding that second derivative. All right, so let's go through. Our function is y cubed equals 4x. So we're going to find the first derivative. Let's take the derivative of the left-hand side. Derivative there, we will have 3y squared dy dx. And on the right-hand side, our derivative is just 4. So dy dx is 4 over 3y squared. Or you might think of this as 4/3 y to the negative 2. Great. Are we done? Well, we're done finding the first derivative, but now we need to find the second derivative. How do we do that? Well, the second derivative is just the derivative of the first derivative. So to take the derivative of dy dx with respect to x, that is the second derivative. So our second derivative is, now we're going to take the derivative of the right-hand side. Here we're going to have a chain rule that happens, so we'll bring the negative 2 down. So we have negative 8/3 y to subtract 1 from the power. Then we need to multiply by the derivative of the inside. The inside is dy dx. And so our second derivative is negative 8 over 3y cubed. What are we going to do with that dy dx? I don't like having a second derivative being rewritten in terms of our first derivative. So what can we do with that dy dx? How can we get rid of it? Well, up above, we actually solved for dy dx already. So we can replace dy dx with either one of these representations. So I will use that first one. And so our second derivative of y with respect to x is equal to negative 32 over 9y to the 5th. So that is our second derivative. So our first step required that implicit differentiation. Our second step also had some implicit differentiation, but we didn't have to go through all that work to solve for dy dx or to solve for that second derivative because we went through that in the first step. So we don't have to isolate it on one side. It should already be isolated on one side. Great. That is it for implicit differentiation. In our next set of videos, we are going to use these ideas and apply them to word problems, real-world kinds of settings where we are trying to find the best of something. And so when we do that, we are going to apply them to not find the best of something. That's later on. We're going to apply them to find how are some rates related. So we will see you in our next video.